Okay, guys, I think we can start now. So take a seat. So good afternoon, everybody. So last time I started to explain data transfer instruction. So first of all, I want to tell you this instruction similar to something like this, like what you did in C language when we did I is equal to J, I is equal to 2, something like that. Okay, so we don't have equal here in assembly. Instead, you have to use an instruction. Okay, so here we have 3 instruction. One is load instruction. The second one is store instruction. The last one is move instruction. Okay. For load instruction is used if you want to copy from memory. If you want to copy from memory to register. Okay. When you copy from memory to register. Store instruction is the opposite. If you have a register and you want to copy the register to memory. Okay. Move instruction is used if you want to copy register to register. If you want to copy register to register. Okay. Okay. So 2 questions now. Number 1, can I copy memory to memory? The answer is no. We don't have instruction to copy memory to memory. Instead, you can copy memory to register and then from register to memory. You understand what I'm saying? So we don't have an instruction to copy memory to memory directly. A register has to be in the middle. Okay. Another question. What if I want to do something like I is equal to 2, immediate value, which one I have to use? As I'm going to explain right now, if you want to, for example, if I have a register or 0 or 1, whatever, I want to write immediate value to this register, you have 2 options. You can use move or you can use load. But I prefer load because move is only for if you want to copy a byte. More than a byte, sometimes it works, sometimes it doesn't work. I'm going to tell you why. Okay, but anyway, so let's go to the details. So and also I want to tell you, for example, here for store, you can store in the memory. I can store a word, or you can store half a word, or you can store only a byte. And this is a little bit tricky. I want you to understand what I want to say. Okay, look here, guys. For example, if this is a location of 20000, this is a location. And then I want to use store in order to copy a byte. So in this case, I'm going to use the address 2000. And in this case, it's gonna written only in one place. Makes sense, right? But this is if you want to write a byte. But if you want to write a word, starting from 2000, so it's going to take 2 bytes, 2 locations, 2000 and 2001. Make sense? Okay, so here, as you will see, store can be used if you want to write a byte, if you want to write half a word, also if you want to write a word, and that's what we did until now. We used it to write a word. In case of if a word, so we are going to write in four locations. Okay, so let's. This is like an overview. Let's give you the details now. Yeah. So for load, yeah. As you see here, guys, for load, we have this instruction for load. Listen to me. Number 1, we have load. That's what we have used so far. Okay. And we have load byte. This one, in this case, you are gonna load a byte. And this byte, you are gonna load a byte and store it in a word. Okay. This one load half a word and store it in a word. Okay. So we have this. So this one, you are gonna load a word and store it in a word. So I'm gonna read a word to put it in a word. The size is the same. That's okay. But for this one here, I'm gonna read a byte, but store it in a word. This one here, I'm gonna read half a word and store it in a word. Make sense? And these 2 are similar to these 2. The difference is here, these 2 unsigned numbers. Or this one is going to consider the number unsigned. This one considers the number signed. Okay, so what this means? Okay, let me let me explain first. Look here, guys. If you wanna, I'm gonna tell you the main point here. So the main point is that, look here, guys. If I have a word 32 bits and I wanna copy it to a word 32 bits. Oh, this is a very easy case. You just copy bit by bit. Yes, that's okay. Is that okay? Now, if you have a byte and I want to copy it in a word, that's what we call extension. You need to extend the byte to a word. Extension. So what extension means? It means what the value of this byte, I want to get the same value, but stored in a bigger place. You got what I'm saying? That's what we call extension. So if this one is storing 23 or 22, so this one also should be 22, but in a bigger space. Is that okay? That's what we call extension. Listen to me. We have two types of extension, signed and unsigned, because they are different, okay? Make it easy. So first you should understand what I mean by extension. Extension means I have a number in a certain size. I want to store this number in a bigger space. Okay, that's why I need to extend it. Okay, but I need to get the same number. Okay, but in a bigger space. Anyway, so number one, we have two types of extension. Number one, we have unsigned extension. So if your numbers are unsigned, all what you have to do, guys, I'm gonna get this number. I'm gonna put it here in this byte, and then I'm gonna put zeros everywhere. That's what we call unsigned extension. It's guaranteed you will get the same number. Give me example. The easy example, if you have here FF. FF means 255. If I want to store FF here, and also I want to get 255, it has to be FF 000000. Okay, guys? So again, if your numbers are unsigned, you want to extend them, we have an instruction for that, okay? All what I need from you now, number one, to understand what is the meaning of extension. Number two, what is the difference between unsigned or signed? Okay, now let's talk about signed extension. Number two, if your number is unsigned, if your number is signed and you want to extend it, so you have to use an instruction for signed extension to get the same number. Anyway, so if your number are signed, now there are two cases. If the number is positive, okay, so in this case, I'm gonna put zeros similar to this case, and it's for sure I'm gonna get the same number. Is that okay? However, if the number is negative, in this case, in order to get the same number, you should not put zeros here. You have to put 1, 1, 1, 1, 1, 1, 1 to get the same number. Okay, no, that's too difficult. Okay, I'm gonna make it very simple. Look here, guys. As I explained before, if it can be -1 or it can be 255. We agree on that, right? So if this number is unsigned, so it has to be 255. So when I extend this one, I have to get 255. And to do that, I'm gonna add zeros here. So if you do that, I'm gonna get 255. So that's okay, because it's unsigned. However, if this number is signed, so actually this number is -1. So after extension, I have to get -1 as well. In order to do that is actually, I'm gonna put F, which is 1, 1, 1, 1, 1. Okay, guys? Conclusion, to make it simple, conclusion. If your number unsigned or signed but positive, put zeros on the left. You are gonna guarantee you are gonna get the same number. However, if your number is signed and negative, put ones. Because if you put 0, you are going to get a different number. Okay? So here, if I put 0, I'm going to get 255, not -1. Okay, guys? So now we have two instructions. We have two instructions, one for signed, one for unsigned. One of them can work on bytes. The other one can work on half words. Okay? So let me show you here. Any questions? So as you see here, guys, so, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, We have this load instruction here. Okay. So this load instruction, guys, this one is for 30 bits. So this one is going to copy 30 bits from memory, store it in 30 bits. Okay. This one for byte, and this one also for byte. That means I'm going to read a byte, not a word, a byte from memory. So I'm going to read only one location. And then I'm going to store it in 32 bits extension, right? And we have two of them. We have one of them for unsigned and the other one for signed. Okay, guys? Any questions? Again, the tricky part is when I say I want to, this is a memory location 2000 or whatever, 2000, for example, okay? When I say I want to read a byte from 2000, so I'm going to read only this one. When I say I want to read half a word from 2000, so I'm going to read this two. When I say I'm going to read a word from 2000, so I'm going to read this four. Is that okay? So this one, because this one is going to load the word, so this one actually is going to read four bytes from memory. But this one byte and this one byte, so it's going to read only one byte. But because this byte, I'm going to store it in a word, I need to extend it. So I'm going to take from the memory a byte, but I'm going to extend it, store it in a word. Make sense? So we have also another two, as you see here, guys, and this one. This two is going to read 16 bits. Okay, so this case, we are going to read two, your number is half word. And also, it's going to store the half word, it's going to store it in a word. That's why it's going to also do extension. Okay, guys, any questions? Okay. So I'm gonna post today's coming lab. So in the coming lab, you will do this one. So what you are gonna do, you are gonna have an array of bytes. Then, so you have array of bytes, and you have array of words. Then I'm gonna ask you for every byte here, you have to extend it. You have to store it here. So this element I'm gonna store it here in word 2 times. One time for signed and another time for unsigned. And I want you to see by yourself how extension is done. Okay, guys? I'm going to give you, forget the lab now, I'm going to give you more details, but let me finish here. Any questions? Okay. So what I'm saying here, guys, using this instruction, you can read from the memory word, store it in a, always we store in a word. Okay, so this is always we store in a word. But I can read a word, or I can read half word, or I can read a byte. But if in case of half word or a byte, you need to extend it, right? It should be extended. Any questions? Let's come to store. Store, yeah, so here, the first one, which we used before, you have here store. So store, you have a word, okay? You can store this word in a word in memory. Okay, so word, you store it in a word. And this is this case here, this case. Okay? The other case is you have a word, but you are gonna store a byte in memory. You have a word, but you are gonna only store half word in memory. But how? Okay, I got confused. You told us if I have a byte, I can store it in a word by extension. That's true. The small size, I can make it bigger by extension. Is that okay? But now this is the other case. It's you have here, you have a big size, and then you are gonna store it in a small size. You understand what I'm saying? Because this one is a word, I'm gonna store it in a byte. How this is done? Very simple. If it is a byte, so actually I'm gonna store this byte, the least significant byte. So here you only wanna store the first byte here. If it is a half word, so actually you are gonna store these 2 bytes. You got what I'm saying? You don't need extension here, guys. Extension is needed if you have something small, you want to store it in a bigger space. So you don't need extension. Okay. Anyway. So yeah, I have just example to understand what I want to say here. For example, if I say here, look at this example, guys. Load byte. And this one is unsigned. So what it means when you see something like that, that means I'm going to read a byte from this memory. I told you before, Once you see the brackets, that means it is a memory. So I'm going to read a byte from this memory. I'm going to store it in R1. So R0 is here, okay? Because this instruction is going to read a byte, so only I'm going to read this one, because this instruction for a byte, okay? So I'm going to read this one, but I'm going to store it in a word. The question is, how? Because this is small size, you are going to store it in a bigger size, so you need to do extensions. That's true. And because this instruction for unsigned, the way I'm going to do extension just by adding zeros. Any questions? Let's have another example. Now, same thing, but here I'm going to say load H. So here you are going to read half a word from this location. When I tell you from this location, I want to read half a word. So what I'm going to do, I'm going to read these two. And you are going to read these two, but I'm going to store them in a word. Okay, so I need to do extension. And because this extension for unsigned, so I'm going to add zeros. So you can see here, guys, I got these two here, and then I add zeros because this is for unsigned. Any questions? I'm going to repeat the same thing again, but in case of signed. Okay, so in case of signed, let's see. No, this is, I'm going to come to signed, but this is load. So load here, guys. So here I'm going to read a complete word. So I'm going to read these four, right? Word to word. Okay, and you can see the difference between these three. So one of them is going to read a word from memory. The other one, you are going to read a byte. The other one, you are going to read half a word. Okay, in all cases, I'm going to store the value in a word anyway. Okay. Any questions? Okay. Let's have example if I use signed. So everything, I'm going to repeat everything again, but the only difference is that here, because this one is signed, sometimes I do extension using FFF or 1111111 or using 0000. Okay. It depends on the number you want to extend. This number is a negative number, because if you look at E is actually, I think, 1110, okay, and then 0001. So this number is a negative. Because this number is negative, when I extend this number, so I have to repeat this one, 1111, F. Okay, guys? By this way, I'm gonna get the same number. Any questions? You can see the difference between this one and the difference between this one. This one is unsigned. This instruction is unsigned. That's why this instruction is going to put zeros. This instruction is signed. That's why it's signed, and this number is negative. That's why this one is going to put 111. Any questions? Same thing in case of half a word. In same thing. So here I'm going to read half a word this way. Okay, as you see here. And then I'm going to extend. I'm going to do extension. I'm going to extend it. And because this one is negative, how can you know it is negative? By the way, this is one number, guys. So you only look at this is 16-bit number, 16-bit. So you have to look at bit number 15. We started from bit 0 until bit 15. So you have to look at bit 15. If bit 15 is 1, that means it's a negative number. So here you have to add 1111. If bit 15 is 0, that means it's a positive number. You have to put 000. Any questions? Any questions? Okay. Same thing for store. Okay, same thing for store, but store doesn't need extension. As I said, in case of a store, for example, if this one here, guys, here, that means I want to copy a register to memory. Okay, this way. And so this is R1 here. So I'm gonna copy this one, this 4. I'm gonna copy them here, starting from this location pointed by R0. Okay, guys. So because this one is a word, so it's gonna be stored in 4 locations. It's a word. But you have another one. I have another instruction, H. Okay. So in case of H, that means you are gonna store half a word, 2 bytes. So what's gonna happen? So here this is register R1. So I'm gonna only store these two bytes here. Make sense? Same thing if it is a byte. Yeah, here. So I'm gonna store this one only in 1 location. In case of a store, there is no signed or unsigned. Please. Why? We use signed or unsigned in case of extension. A store is not doing extension. Okay, guys? So now I have 3 instructions. I have register that is 4 bytes or 32 bits, I can store it, I can store everything. Or you can store only this half, or you can store only the first byte. No extension here. Any questions? Okay. Yeah, this is just another example. So I'm not gonna go, I'm not gonna go through it. It's just very easy because this one you are loading half word here. Here you are doing extension, and because this number is this one for unsigned, that's why you put 00 here anyway. This one load, but this is signed byte, and this is the byte here, and because this one is signed, so here this is the byte is here, but you need to put f here. So nothing is new, just example. Any question, guys? Okay, yeah, sure. So yeah. Previous one. In store or load? So yes, this one. Yeah. So those two on the last 60 bits of that, will those still be there since you wrote? Yeah, yeah. You mean these two? Yes. Yeah, they are going to stay there. Because keep in mind, we copy. So we take a version from this one, we copy it to here. Copy. Okay? So this is the source, man. We don't change the source. We change the destination. So if there is something here, if there are something here, we are going to override them. So they are going to be gone, and they are going to store the new values here. Yes.
So to go back over the signed extension. Like
yeah.
Is it always going to give you the FFFs in front, even if not the negative number?
No, signed. In case of signed numbers, you can do extension using zeros or ones. If the number is positive, to get the same number, you have to put zeros. When you go home, you can try it by yourself. Again, the purpose of extension is I have a number in a byte. I want to get the same byte, but in a bigger space. To get the same number, in case of unsigned, you have to put zeros all the time. In case of signed, if the number is positive, put zeros. If the number is negative, you have to put ones. Once on the left, you are not going to change the number in case of negative number. For example, if f is -1, if is still -1, if is -1. You get what I'm saying? However, if 00, it becomes 255. You change the number. Anyway, okay. Okay, now we have instructions here to store more than one instruction at once. Okay, so here we have an instruction, guys, to store, for example, what if I want to store in the memory 3-4 registers? Okay, for sure you can write 3-4 instructions. You can write 3-4 instructions. Every instruction can store one register, or we have an instruction here that can copy at once 3-4 registers at once. Okay, so for example, this is the format of this instruction. So start with store multiple register, load multiple. So again, the difference between what I'm teaching now and between what I taught before, how store and load for one word, one register. These ones can be used for a list, okay, in one instruction, okay? So anyway, so what happens here, guys, you have a list of registers here. I want to store the list of registers, okay? And this is the pointer. Here you have to put the pointer here. So there should be a pointer at R0. And then here, starting from R0, for example, I want to store two registers, or I want to store 4 registers. Is that okay? So here you have to tell me where is the pointer, in which the pointer for in the memory, okay? Maybe this is, here we use memory, but without brackets, but maybe this is a very rare case. Always when you see brackets, that means it's a memory. Anyway, so here, so this one, you are gonna store this list to the memory, or maybe the opposite. I can read from the memory 3-4 words, store them in the register at once using one instruction. Very interesting. Why? Because this can make your program faster. Instead of writing 3-4 instructions to load or store, I can do it quickly using only one instruction. Okay. One more thing here. What happens is that, look here, guys. If you have a list, here you have list of register. Okay, you list of register. You need a pointer. You tell me you have to start from this location, and then you have to write 3 registers. So this is R0. I'm gonna put here 1 register. Then this one is gonna increment to come here, add another register. This one is gonna come here to add another register. Automatically, you don't, just one instruction is gonna do that. Okay. So in this case, you have 4 options, because again, you have a pointer. You need to, every time you need to increment the pointer. Is that okay? Because you are gonna write more than one. You are gonna write more than one register. Okay. However, we have more than one case. As you see here, guys, you need to replace XX here by one of these words. So here you can put IA here. You can put IB. You can put GA. You can put GB. So what is the difference between them? I'm gonna tell you. The difference is that one of them is increment after. What this means? It means this is a pointer here. I'm gonna write and then increment is a pointer. Increment after. Another one, increment before. So what's gonna happen in this one is gonna increment the pointer first and then write. Increment, write. Another one, decrement after. After what? After you write. So write first and then decrement. This one, decrement before. Okay, guys? It's confusing. Okay, I know it's confusing. So I'm going to make it very easy now. I'm going to give you an example you will understand. But the main idea, what is the main idea here? The main idea is that, okay, number one, I want to write or read multiple registers, okay, or multiple words at once. Got what I'm saying? All what you need, you have to give me, you need to give me the list of registers. This number one. Number two, you have to give me the pointer where I have to start. Number three, you have to tell me what should I do? Should I write first and then increment the pointer? Or you want me to increment the pointer first and then write? And so on. So I have a very good example to understand exactly what we mean. Okay, so let's come here. This is a very good example. Look here, guys. So as you see here, look at this example. Here, I'm gonna say STM, and then I'm gonna use one of the prefix I told you about, IA or IB or DA, DB, okay? And then you have to tell me where is the pointer. It can be any register. It doesn't need to be R0, okay? So here my pointer is R0, okay? And then this is the list of registers. So that means here I wanna store 4 registers. I wanna store 4 registers. Is that okay? Starting from the pointer here. Yes. So let's see the first one. Okay, guys. In all cases, we start from here. So in all cases, I'm gonna start from here. That's okay. Let's start in this one. This one, it's called increment after. Okay. So what's gonna happen here in this one, I'm gonna write R1 first. After I write I1, so I'm gonna increment. And then I'm gonna write R2. Then I'm gonna increment. Then I'm gonna write R3. Then I'm gonna increment. So that every time you write and then increment. At the last one, you are gonna write and then increment. Okay, wait a second. Why you are, first there are several problems here. The first problem is this list, you wanna write R3, R1, R7, R2. But here, you write R1, R2, R3, R7. Order, what is the order? Okay, the answer is, the order doesn't matter. Okay, what's gonna happen? Always, the smallest register is gonna come first. You got what I'm saying? This is how it works. That means, so this one is gonna be, what? Write it in the order, whatever order you write, it doesn't matter. Okay, so what's gonna happen, the smallest one is gonna be written number 1. Next one, number 2. Next one, number 3. Next one, number 4. Is that clear? So the order doesn't matter. Always the smallest number here is going to be written number 1, number 2, number 3. This number 1. Okay, number 2. There is another problem. Okay, what is the other problem? You told us every register is 32 bits. That means It has to be stored in 4 locations. Why you store here everyone in 1 location? The answer is, I didn't tell you everyone here is 1 location. I didn't say that. I didn't say that. Actually, everyone here, but just here because I want to focus on the concept of storing words. But actually, everyone is 4. So this one actually 4 bytes, 4 bytes, 4 bytes, 4 bytes. Is that okay? But just I want to make it simple. So here I just put it in one block, but actually it's 4 bytes. Is that okay? So let me say it again what happened. So what happened here, guys? We agree. Whatever the order you have, it doesn't matter. It doesn't matter the order. So we are going to do R1 first, and then R2, and then R3, and then R4. So now I'm going to store 4 words starting from location R0. Is that okay? And because this one increment after, so how this one is going to work? R0 is here. Remember, in all cases, R0 is here. Okay? So what's happening here, I'm going to store R1, and then I'm going to increment. Then I'm going to write R2 and then increment. Then I'm going to write R3 and then increment. Finally, I'm going to write R7 and then increment. Okay, guys? Okay. There is another way. The other way is increment before. Increment before. This is the same idea of the addressing modes when we have a pre-index, right, and post index. It's the same idea. So what's happening here, guys? Increment before. So this one is going to increment first and then write. Increment and write. That's exactly, again, remember we started from here. We started from here. So this one is going to increment, write R1. Increment, write R2. Increment, write R3. Increment, write R7. Is that okay? This one here, decrement. Decrement. Again, it depends on how you have 4 options. So it depends on how you want to use it, or how you want to write it. Okay. This one, if you want to decrement, so you are gonna go this way. So you have the option. If you want to start from here, you can go this way or you can go this way. If you are increment or decrement. Okay. So in case of decrement, again, in all cases, I'm gonna start from here. So this one decrement after. So I'm gonna write here in case of decrement, guys. So here we are gonna start writing from the biggest address. Okay, this is how it works. So if you increment in these 2 cases, in case of increment, you are gonna start writing. You start writing from the smallest registers. The smallest here is smallest in the number. Okay, but here you are gonna write. So here, because in case of you decrement, so I'm gonna start with the big one first. Okay, anyway, as you see here, this one decrement after. So I'm gonna write and then decrement, write, decrement, write, decrement, and so on. Okay, guys, any questions? Okay, so here only one thing is left. I didn't explain it yet. This explanation mark, what this means. You have the option. You can put it or not. If you put it, what happens? If I don't put it, what happens? Okay. If you don't put it, okay, so that means after you execute the instruction, you are not going to change R0. Yeah, R0 is going to be the same. Okay. Still, you are going to do exactly the same thing, but you are not going to update R0. Is that okay? So everything will be done the same, but R0 is going to have the initial value. Whatever the R0 is going to stay the same if you don't put the exclamation mark. But if you put the exclamation mark here, that means R0 is going to be updated. So if you start from here, this is the last R0, so this is the new value. Okay, this is the new value. So you are going to update R0 with the new value. Okay, this is exactly the same instruction, guys. It's the same thing, but here I'm using load instead of store. Load. So here I want to, using this instruction, guys, here, I want to read 4 words. Very interesting instruction because you can read 4 words at once. You are going to read 4 words and you are going to store them in 4 registers. Is that okay? Using the same idea. For example, assuming I'm going to start from here, as you see here. So this one here, increment after. Okay. So because I'm going to start from here, so I'm going to read and then increment. So what's going to happen? I'm going to read this one. I'm going to put it in the smallest address, R1. Okay, and then this one, so read and then increment. 4 is gonna go to R2. Okay, as you see here. 8 is gonna go to R3. 12 is gonna come here, and then you increment because you read and then increment. This one increment to be 4. Increment to be 4. That means in the first time, I'm not gonna read this one. Yes, the pointer is here. Yes, R0 is here, but I'm not gonna read this one. I'm gonna start reading from this one. Why? Because you increment first and then you read. Okay. So in this case, 4 is gonna go to R1, as you see here. 8 is gonna go to R2, and so on. This one here, in case of decrement, as I told you, in case of decrement, here you are gonna start from the bigger ones. Okay, so that means because this one decrement after, so I'm gonna read this one, okay, and then decrement, read this one and decrement. So I'm gonna get this 4, and these 4 are gonna be, there is no negative 0. Sorry, this is 0. So here what's gonna happen here? This one is gonna go to R7. This one is gonna go to R3, and so on. Any question, guys? Very good example. Okay. Okay. Now I'm gonna move to move instruction. Okay. I told you move instruction is used if you wanna copy register to register. Is that okay? And that's very easy case. So in this case, we have this instruction move. We have another one is called to move not. Okay. So this one is gonna copy register to register. This one is gonna copy not, is a once complement of the register. Okay, let me give you example. For example, look here, guys. This one here. When you say move R4 and R5, what it means? It means you are gonna copy R5 to R4. So after you execute this instruction, R4 should equal to R5. You are gonna copy R4 to R5. This exactly when you see language, when you said R4 equal to R5. Oh, sorry, R4 equal to R5, yes. Okay, guys? This one, move in, move not. So this one, actually, you are gonna copy not R5, but the ones complement of R5. Once we flip the bits of R5. But this one does not change R5. I'm gonna get the value of R5. I'm gonna calculate the ones complement of this value, store it here. But still R5 is gonna have the original value. You understand what I'm saying? So I didn't say you are gonna change R5. No, I'm gonna get the value of R5. I'm gonna flip the bits. I'm gonna store it in R4. Okay, guys? Anyway, so you can do it this way. One of the things you can do something like that. For example, you can say here, or I'm gonna talk about this one in a minute. Okay. So the first thing here, guys, what I explain, move and move not. Move, both of them are used if you want to copy register to register. One of them is gonna copy the register, but the other one is gonna copy the ones complement of the value 0. Okay, that's fine. We have 2 more register. These two can be used if you want to copy general purpose register to another general purpose register. However, we have 2 more here. This one here. This one is used if you want to copy a special purpose to a general purpose register or general to special. You got what I'm saying? I told you before, if you remember, long time ago, I told you we have general purpose register and we have special purpose register. Okay. So if you want to copy, and that's most of the time we're gonna for sure use this one. For example, here, if you want to copy R0 to this special purpose register, or you copy this special, oh sorry, the opposite. You want to copy this special register to R0, or you want to copy R0 to this special. So in this case, you have to use one of these 2. Okay, guys? But most of the time, you are gonna copy general purpose to general purpose. That's why you are gonna use these 2. Any questions? So what I learned, what I taught so far, guys, number 1. If you wanna copy register to register, use move. Very easy. If you wanna copy memory to register, use load. If you wanna copy register to memory, you use store. Is that okay? Only one thing is left. What if I wanna copy immediate value? No, before this one. What if I wanna copy memory to memory? We don't have an instruction to do it. The way you have to do it, you have to read the memory, put it in the register, and then you have to store this register to the memory. Is that okay? Okay. The second, another thing I didn't teach yet, that if I want to copy immediate value to register, immediate value, a number to a register, okay? In this case, guys, we have two options. You can use move or you can use load. And I prefer load. I'm going to tell you why. Okay, so what you can do is that you can say move R0, for example, and here you have to put hashtag 0xFF. Yeah, you can use this one. By this way, you are going to copy immediate value to R0, okay? Can be any number, can be 2, can be 3, any number, okay? Or, as you did in the last lab, I can say load register, load R0, comma, equal, not hashtag, equal 2. So both of them are going to do exactly the same thing. This is if you have a value, if you want to copy a value to a register. By the way, this one is similar when you say load R0, comma, equal array, as we did before. This one is exactly like this one. Why? Because the compiler is going to replace this one with the address by a number. So eventually, it is equal a number. You got what I'm saying? So now, why, first of all, why you are telling us it's better to use load instead of move? I'm going to tell you why. Because move is going to work only if this one is a byte. So if this one is a byte, it should be okay, right? However, if it is greater than a byte, so there is some restriction with move. If it is greater than a byte, it should be in a certain pattern, in a certain format. Otherwise, it's not going to work. You understand what I'm saying? But for load, it's going to work all the time. So I think for peace of mind, just use load. You understand? If you want to copy immediate value to register, you just use load. Because as I'm explaining here, guys, as you see here, if you want to use move, you can say here move, hashtag, and then you can put the number here in hexadecimal, in binary, in decimal, and so on. Okay, and then this value is gonna store. If this value is a byte, it is okay. Sometimes it works for more than a byte, but it has to be a certain format. This what you mean by certain format? It has to be written something like that. There should be some immediate value, and you are gonna do like rotate. So if anything has this format, it may work. Okay, I'm gonna explain rotate later. So if your number can be represented in this format, move is gonna work. Otherwise, move is not gonna work. So my opinion, just use load and that's it. Okay, guys? Any questions? Okay. However, I want you to bring this to if you see here, don't be confused. If you want to use move, you have to put here hashtag. But if you want to use load, you have to put here equal sign. Equal sign. Is that okay? Okay. We have also the last two instructions for move here. I have the last two instructions for move. We have move W and move T. This is the last two instructions for move. Move W and move T. What is the difference between them? Move T and move W. I'm going to tell you what is the difference. Look here, guys. So let's start, for example, with here you put 16-bit. In both cases, you have immediate value 16-bit in both cases. Is that okay? Okay. So, and in both cases, you are going to write 32 bits. In both cases, you are going to, the register, the register is 32 bits. But the number you have is only 16 bits. So what is the difference? I'm going to tell you. Here, in case of move top here, this is RD. RD has, this one is 16 bits and this one is 16 bits. Is that okay? So this one move top, whatever you write here is gonna come here. And this, what about this one? No change. This one will be the same. So you are gonna write to the most significant half word. Again, you have two half words, right? So here I have what this instruction is gonna do. This instruction is gonna copy 16 bits to the most significant 16 bits. This one. What about this one? No change. This one is not gonna change anything. Okay. What about this one? Okay. Actually, this one, what this one is gonna do is gonna copy here. The 16 bits are gonna come here but this one is going to manipulate this one. It's going to put zeros here. So move W. It's going to write here 16-bit and then put zeros. The other one, move T, is going to put here the 16-bit here and then nothing here. It's going to leave it without a change. To understand better what I said, you have to understand examples. So that's why I have one example here to understand better. Let's see this example. Look here, guys. When I say move W, R0, and then I have this one. So this one, as you see here, it is 16 bits. So how this one will be stored? Okay, it will be stored as you see here, 0, 0, 0, 0, 4, 4, 3, 2, 2, 1. Okay. So the 16-bit are gonna come here, but these ones are gonna be zeros. Okay. Okay, but for the other one here, for top here, this one is gonna come here and no change here. So as you see here, guys, so here, I'm not gonna change this part. It will be the same, but I'm gonna change only this part. Any questions? Okay, so here I'm asking you, is the order here is important? So if I put this one first and this one, it's gonna be the same. If I change the order, the answer is no. And let's see the result. For example, if I change the order, this one is gonna come here, as you see here, guys, and then here, whatever there, right? Because this one is not gonna change this part. However, when you write this one, you are gonna put 0 here. So the result you are gonna get here is gonna be different. For sure, the order matters because move W is gonna change. It's gonna change the most significant half word. Any questions? Any question, guys? Okay. Here, I want to teach something here, guys. There is something we call it pseudo instruction. What it means, pseudo instruction? Pseudo instruction means it's not a real instruction, right? Pseudo means it's not real, right? It's not real instruction, pseudo instruction. What it means, okay, we agreed from the very beginning. Any instruction should have a machine code, right? And any instruction should be executed by the hardware. That is what assembly is. Is that okay? However, this instruction is not supported by ARM. This instruction does not have a machine code. It doesn't have hardware. This instruction, okay, it doesn't have a hardware. Okay, so it doesn't have a machine code. Okay, however, the compiler, you are gonna write this instruction. The compiler is gonna replace it with another instruction that can be supported by the hardware. So, okay. So you are telling me this instruction, you are gonna write some instruction here. That's true. The compiler is gonna replace it with another instruction that can do the same thing, but is supported by ARM. Is that true? Yes. But why I do this way? We do this way in order to make programming easier because it's more convenient. If you want to do something, just write it this way, and the compiler is gonna take care of it. Okay, make it simple. It's somehow like the techniques of high level programming. So for sure, it's not high level, but something like that. If you want to do something somehow difficult, just call the subroutine will take care of it. Something, but there is no subroutine here for sure. Okay, so what do you mean? I'm going to tell you. Here we have one instruction that is pseudo instruction. This instruction is load, for example, R0 equal 20. I told you I'm going to use this instruction if I want to write 20 to R0. Is that okay? Actually, we don't have this. We don't have this instruction. Load, to be accurate, load instruction should only be used, okay, if you want to copy or what's going to happen here is the compiler is going to replace this one with another instruction to do what you want to do. So what I want to do here, I want to write 20 here, okay? So the compiler is going to replace it with someone else. And you should have observed that before. You should have observed that if you go to the first lab, and I think the last lab, every lab you did, you notice you are gonna write this instruction this way. But when you go to when you do debugging, you will see a different instruction. You're not gonna see this instruction because this is a pseudo instruction. I'm gonna give you more details for that. So what happens now, guys? Every time you do something like that, load and then a register equal label or expression, what's gonna happen? So this is what we can use here. When you say load R1, you are gonna copy FF0 to R1, you are gonna copy FFF to R2, you are gonna copy the beginning address of array in R3, and so on. That's what, okay? Again, this instruction does not exist, but what's gonna happen is that this instruction is gonna be replaced by one of two instructions, okay? Either move instruction, okay? Either move, but you have just told us move doesn't work all the time. That's true. That is why if move doesn't work, it's gonna go for another one. You get what I'm saying? Again, you don't need to worry about that because I'm explaining what the compiler is gonna do for you. Okay, so this instruction is gonna be replaced by one of two instructions. Either move, this move, or move something like that, or it's gonna be load, but here I'm gonna put an offset related to PC. I don't understand. Okay, I'm gonna clarify it. So what for now, what I want to say, in order to make programming easier instead of doing something difficult like this one by yourself, you can just use a pseudo instruction and the compiler is gonna do it for you. Okay, so all what you have to do this one, and then you are gonna see when you do debugging, the compiler is gonna replace it with move. If move can work, because I told you move may not work all the time, because move is gonna work if it is a byte. More than a byte, there should be a certain pattern, otherwise it doesn't work, okay? So if move doesn't work, it's gonna do it in a different way by using PC and offset to numbers. What do you mean? I'm gonna just give me, yeah. For example, look here, guys. You should have observed something like that, okay? So if you write in your program something like that, load R5 0xFF. So when you go to compiler, when you go to the debugging, you are not gonna see this instruction because this is a pseudo instruction. You will find this instruction. So what happened? The compiler is gonna replace this one with move. Okay, guys, is that okay? Because move can do the work here. Okay. However, this is not always the case. Look at the other case. This one here, this one cannot be done by move. Okay, so what the compiler is gonna do? What the compiler is gonna do is, as you see here, guys, look. The compiler is gonna replace it with load R, and then here R5, and then here, and then this number is gonna store this number at the end of your program. So if your program is here, all numbers are gonna be stored here. And then here, I'm gonna use the address to the location of this one here. That's exactly what happened. Look here, guys. For example, I'm gonna say load R5, and then PC0. What it means? It means PC plus 4 plus offset, which is 0. Okay, so this one will give you the address of this one here. And from here, so this address here is gonna be replaced by this address here. Yeah. So make it easy. So these immediate value numbers, okay, are gonna be stored in memory, okay, after your program. And then I'm gonna use address to point at them, just to go and read them. Okay? And to use the address is gonna be, I'm gonna use PC, how far it is from PC. So PC is here. So I'm gonna say, yeah, so this byte or this word is stored in PC, for example, plus 20. It's gonna go there and read it. Anyway, you don't need to worry about it. So I don't want to overcomplicate it because actually the compiler will do it for you. But you should observe if this is your program, at the end of your program, you have some numbers here, as you see here. Some numbers here, okay? So this instruction is gonna write this value somewhere here, and then it's gonna use PC. It's gonna use PC as a pointer. So it's gonna and it's gonna put some number here. I think I have another example here, as you see. For example, guys, if I want to do something like that, so as you see here, this one move doesn't work in this case. That's why you can see we added two numbers here, and this one here is gonna be PC plus 4. 4 is the offset, so PC plus 4, and automatically is gonna add 4 as well. So this one is gonna bring you to here, which is this address here for the first number. For the second number, you are going to come here to read this one. Anyway, any questions? Very simple conclusion. Okay, make everything simple. Very simple conclusion. If you have immediate value, you want to write it to register, you can just use this one. You can say load R2, for example, equal 327, whatever. Okay. You should understand this is not a real instruction. This is a pseudo instruction. Okay. This one is going to be replaced by another instruction, but the compiler will do it for you. But why we do that? Just to make more convenient for us as a programmer instead of overcomplicated things. Any questions? Okay, so this is just a summary of the instruction I have taught right now. I give you here several examples. Maybe I'm gonna quickly go through this example. So here, for example, here, when you do something like that, so here you are gonna store the beginning address of array in R0, and then when you do something like that, so R0 now is the pointer to the array. Here, I'm gonna read the byte from memory. Sorry, I'm gonna read the word from memory. I'm gonna store it in R1. Here, you are gonna put this immediate value in R2, right? And so on. So just to go through this example, it's just a very simple example. Same thing here, nothing is new. Here, I just wanna tell you, if you wanna use move, you have to put here hashtag. However, in case of load as a pseudo instruction, you have to put equal here. Don't be confused, equal. If you put hashtag, it's gonna give you error. Here it should be equal. Okay. Maybe I wanna go through this one also again, quickly. So here, guys, you have two arrays. This is one array of bytes, and this is array of bytes, okay? So here, I'm gonna use R1 as a pointer here, R1. I'm gonna use R0 as a pointer here, or maybe it's the other way. No, that's correct. So here, I'm gonna, the beginning address, I'm gonna put it in R1. The beginning address, I'm gonna put it in R0. Is that okay? I have to, that's what you did last time. You have two arrays, you are gonna use two pointers. And then I wanna copy. So I'm gonna copy a byte from here to byte here, byte here, byte here, byte here, byte here, okay? That's exactly what I did. Look here. So here, I'm gonna copy load byte. So I'm gonna copy a byte from the location pointed by R1, put it in R2, as you see here, right? And then I'm gonna copy it back to the location pointed by R0. Okay, so I wanna copy this one to this one. I wanna copy this one to this one. I wanna copy this one to this one. Is that okay? However, I don't have an instruction to copy memory to memory. So what's gonna do, I'm gonna copy a byte from this location, okay? Increment the pointer, because every time I have to increment the pointer, right? But I don't need to write an instruction here because this one is done automatically using these two instructions. Is that okay? That's it. So here, this is here. Actually, I'm going to explain it later for sure. Here you have for loop. Here you loop. So you have, this is the body of the for loop. For loop, you loop. In every iteration, I have two arrays. I'm going to copy byte to byte, increment the 2 pointers. Copy byte to byte, increment the 2 points. Copy byte to byte, increment the 2 points. Until I find 0. Once I find 0, I'm done. Because I'm saying that once you find 0, that means this is the end of the array. Okay. Anyway. So just I want to say, forget for sure the loop for now, but this is a loop. I'm going to explain it later. You loop to here. You just see something like that. You are going to copy a byte, then you are going to write a byte. So it's somehow interesting because look here, guys. I'm going to copy a byte, but I'm going to store it in a word, R2. So my byte is here. That's okay, because when I write R2 back, I'm going to write a byte from R2, which is this one. You get what I'm saying? So what I did here, I read a byte, but I read a byte, but I store it in a word. And then I'm gonna, when I copy a word, a byte from a word, so it's gonna be byte. So this one you actually copy byte to a word. This one is gonna copy a byte from a word to memory location. Any questions? Okay. So now I wanna talk. I'm gonna move now to the next section. Next section, I'm gonna talk about arithmetic and logic instructions. Okay. Arithmetic. What kind of arithmetic instruction do you have? Very simple. We have addition, subtraction, multiplication, division. 4. Okay, so let's see them. Start with addition. For addition, that's what we have for addition, guys. We have add instruction, and then you have to give me three operands. Sometimes you give only 2. I'm going to tell you why. So any braces, the braces here means it's optional. That means it may not. You can remove this one. I'm going to tell you what it means if you remove it. I'm going to tell you. But for now, assume we have 3. We have 3. So what this one is going to do? This one is going to add these 2, store the result here. Okay. So as you see here. So I'm going to have 3. You are going to add 2 registers, store the result in 1 register. Is that okay? So this is addition. We have add, and we have add S. What is the difference? Add and add with S and without S. What is the difference? The difference is that, and this is actually, it's going to happen in almost every instruction. Every instruction we have, guys, you can add letter S to it. Almost, not only add, I'm talking in general. Most of the instruction we have the instruction without S, we have the instruction with S. So what S is going to do? I'm going to tell you. You remember in the first week or second week of this course, when I told you about flags, when you execute an instruction, flags are updated. When you updated the flags, you subtract, update quiz, the first quiz. You remember when we did that? Yeah. So actually, the difference between them is this one will do addition, this one will do addition. Both of them are going to do addition. The difference is that this one does not update the flag, but this one is going to update the flag. Okay. So what I want to say, guys, if you need the flags for any reason, you have to add S. If you are going to use the flags after this addition, you have to use the S1. Without S, so it's not gonna update the flags. It's gonna do the addition. If the result is negative, if the result is 0, the 0 flag and negative flags are not gonna be updated. If without S, with S, it's gonna be updated. Okay, guys? Okay, so this is the first 2 instruction. Okay, we have 2 more instruction, one with S and without S. Okay, or now we understand. I don't need to keep repeating any instruction with S and without S. So this S means it is with updating flags or not. Is that okay? Okay. So now, so this is here. You have 3 registers. By the way, this one has to be a register. This one has to be a register. But this one can be a memory location. Can I add a memory location to memory location? The answer is no. Most of the instruction we have here right now, guys, you are not going to find the instructions that can work directly on memory. It has to work on register. That's why I told you before, we need, if you want to do any operation on a value in memory, you have to read it, store it in a register, and then do the operation in a register using load. You have to bring it using load, do the operation, and then you have to bring it back. You have to store it back using store. Okay. Anyway, however, this one, last one here, so this one has to be registered, this one has to be registered. However, this one, it can be a register or it can be immediate value. I'm going to give you examples now. So for example, as you see, look here, guys. Add R0, R1, R2. What it means? It means R0 equal R1 plus R2. Very easy, very easy. Or it can be something like that. Add R0, R1, 3. This one can be immediate value, but this one cannot. You cannot put the immediate value here. If you have immediate value, it has to be the last one. Okay, guys? Okay. Now, you told us you can remove one of them. You can only put 2. I'm going to tell you when you can do that. Look here, guys. If I have something like that, R0 equal R0 plus R1. Okay. In this case, if you want to write this way, it's totally fine. If you want to write this way. However, in this case, if this is the same R0, R0, in this case, you can remove one of them. So you can actually write it this way. So this exactly same thing. So if I write only 2 register, that means the destination will be similar to the first one. You understand what I'm saying, guys? Okay, so like this one, you are gonna add R0 plus 5, and where you are gonna store the result in R0. So this actually, it was R0, comma R0, but you can just make it short this way. Any questions? Okay. The last thing we have here, guys, here, so we have addition, we have addition with S and without S. We have another one here, we call it add with carry. Carry, add with carry. Carry flag? Yes, carry flag. So what this instruction is gonna do, I'm gonna tell you what this instruction is gonna do. Look here, guys. This instruction, you are gonna add register, for example, R1 to R2, for example, 2 register, plus whatever in the carry flag. If the carry flag is storing 0, I'm gonna add 0. If the carry flag is storing 1, I'm gonna store 1. So what is the difference? What is the difference between this one and this one? The difference is they are exactly the same thing. The difference is you are gonna add the carry. If the carry 1, you are gonna add 1. If the carry is 0, you're gonna add 0. Okay, guys? But why? You understand what I'm saying? So you're gonna add the 1 bit, the carry flag. Okay. But why I need to add the carry flag? Why I need something like that? I'm gonna tell you why. Look here, guys. I think I'm talking about it later, but I can jump here. Look, guys, here. If your number, okay, look at the game. The instruction we have, you can add word to word. So if you have a word, you can add word to word. Is that okay? What if you want to add byte to byte? What can I do? Very simple. All what you have to do, guys, if you have a byte, you should extend this byte to a word. The other byte you have to extend it to a word, and then you have to add word to word. Because the only instruction we have, we don't have an instruction to add byte to byte. You have to extend it to a word. That's what we have. Okay, guys? Okay, let me ask another question. What if my number is not 32 bits, is not a word? My number is 64 bits. So assume I have very big number. This number is stored in 2 registers, for example, R0, R1. Okay, so here, this is one number, but I'm gonna store it in 2 registers, 62 bits. So the question is that how I can add 62 bits plus 62 bits, how I can do that? Given that the instruction I have can only add word to word. So how I can do it? Okay, very simple. All what I have to do, guys, is, as you see here, we assume here, this is one number stored 64 bits. This is another number 64 bits. This number is stored in 2 registers. This number is stored in 2 registers. I want to add these 2 numbers together. Okay, so all what I have to do, guys, in the first 2 number here, I have to do addition, normal addition. However, for the second one here, I have to add plus carry. Why? Because if there is a carry resulted from here, I have to add it here. You got it? So now, because of add with carry, I can, again, the instruction I have allow me to store word to, to add word to word. That's the instruction we have. If your number is bigger, still you can do it. Still you can add these numbers. However, you have to consider if there is a carry resulted from here, you have to add it here. Okay? So what if your number is bigger than that? Very easy. So for example, it can be bigger. If you have a bigger number, yes. Here addition, normal addition. Here add with carry. Here also add with carry. That's it. Because if there is a carry resulted from here, I have to add it here. If there is a carry resulted from here, I have to add it here. Make sense? Okay, guys. So let's see, for example, here, how I made it. For example, as you see here, guys, I'm going to add these 2 numbers together. R4 is equal R0 plus R2, as you see here. And then add with carry. Okay, this one plus this one and put it here. If you have more, you can also say add with carry. Okay, guys. Be careful. If you use normal addition without S, it's not gonna work. If you use A without S, it's not gonna work. Why? Because this one is not gonna update the carry. So if there is a carry, this carry is not gonna be stored in the carry flag, right? That's why you have to put here S to make sure if there is a carry trigger from here, this carry has to go to the carry flag because I need it here. Any question, guys? Okay. What I explained here, guys, is related to a bigger topic. Okay, what you mean by bigger topic? I'm gonna see. Look here, guys. In the whole course, the instructions we have are mostly for words, for 32 bits. Multiplication, division, everything is for 32 bits. Is that okay, guys? Okay, but that doesn't mean if you have bigger numbers, that doesn't mean you cannot do it. No, you can. However, you cannot do it using one instruction, but you have to write multiple instructions to do it. And this is a good example here. You understand what I'm saying? So here, the addition instruction we have is for one word, right? So if your numbers are bigger, still you can do it, but you have to use more than one instruction. Same thing for multiplication. I'm going to teach you multiplication. Multiplication, for example, is going to multiply word by word. What if your number is bigger? You still can do it, but you have to use like multiple instructions. Everything you can do it. Division, everything you can do it, but you have to use more than one instruction. It's like algorithm. It's not going to be for sure. This is inefficient because you have to use more than one instruction because this processor is for 32 bits. Right? If you want to do operation more than 32 bits, still you can do it, but for sure it's not going to be efficient because you have to use multiple instructions. Yes. Yes. All right. Thanks. Yeah. So what he said here, yeah, if the number is bigger and use at carry, okay, and then at carry, it's not going to work. Okay, you have to put S here because. Here I put S because I need the carry generated from here. I need it here. Here you have to put S, so the carry generated from here. I need to use it here, and so on. Is that okay? Otherwise, the instruction is not going to update the carry, right? I need the carry in this case. Anyway, any questions? Okay. So that is for addition. Okay, what about subtraction? Okay, for subtraction, as you see here, guys, we have subtraction and subtraction S. Same thing. So as you see here, this one is going to subtract this register again, the last one here, it can be a register or it can be a number. It's going to subtract this register or number from Rn, store the result in Rd. So give us examples. For example, here, look at this example here. Look here, guys, this one. This one, you are going to subtract R2 from R1 and then store the result in R0. Make sense? This one is exactly same thing. This one is exactly same thing, but this one is going to update. It's going to update the flex. It's going to update the flex. Okay. This one here. Yeah. No. Yeah. If you look at this one here, guys. Yeah. So I told you the third operand here, it can be a register, it can be a number. So what this one is going to do is going to actually R1, you actually take, you actually subtract or take away 5 from R1. You subtract 5 from R1. Is that okay? So R1 minus 5 stores the result in R0. I told you this is not allowed. It's not allowed. For example, if I wanna do 1 minus R2, so this is not allowed. You got what I'm saying? Always the second one here has to be a register, and the last one here, it can be an immediate value. So here, okay, you understand what I'm saying? So this it's not allowed. Okay, but wait a second. If it is not allowed, how I can do 1 minus register or 5 immediate value minus register? So again, what I'm explaining here is, as you see here R1 minus immediate value. You can do this way. I'm asking now a question. What if I want to do the opposite? I want to do immediate value minus register. Okay, can I do this way? You told us no, you cannot do this way. What I can do, there is another instruction. This instruction is called, as you see here, reverse subtraction. Reverse subtraction. So in normal subtraction, you are going to subtract this one from this one. This is normal subtraction. In the reverse subtraction, you actually are going to subtract this one from this one. Okay? Give us example. I'm going to give you example here. Yeah, for example here, guys. Here, you are going to subtract R2. You are going to subtract, sorry, R1 from R2. So if I put here a number, and it's allowed to put a number here, it's allowed to put a number here. If you put a number, so what I'm gonna do here, guys, is gonna be 5 minus R1. That's okay. Okay. So again, very simple. We have two instructions. One instruction, normal subtraction, is gonna subtract this one from this one. We have reverse. It's reverse because I'm gonna subtract the second operand from the third one. And usually you will need it in order to do this one. How can you subtract register from immediate value? Yeah, you can do this one. Any questions? Yes.
Yeah, on the RSB line, if that means that it's R2 minus R1, does that
Which
mean
one? RSB?
Yeah. Does that mean that comment has it backward too? Like, should it be R2 minus R1?
Yes. I'm sorry, I'm gonna correct it. Yes. So because this is a reverse. Yeah. So this one, yes, this is R2 and this R1. I'm sorry. So I'm gonna correct it. Okay. I'm making new slides this semester. So yeah, there should be some errors, but I'm gonna. No, thanks for asking me. Okay. I'm gonna correct this one. Okay. Okay, guys. So here, just give me just 1 second. I'm not going to teach anything new, but I just want to summarize what I said. Number one, we have addition. You can add register to register or register to a number, store the result in a register. We have add and add S. And we have add with carry, and we have add with carry S. We have subtraction. So this one is going to subtract the third one from the second one, right? Subtraction with S. And here we have subtraction with borrow. Subtraction with borrow. So this one is exactly the same thing like add with carry. So quickly. So this one, subtraction with borrow, is similar to add with carry. So it's going to be exactly the same thing as I have just explained right now. Here, if you want to do subtraction for 64 bits, okay? So the first one is going to be normal subtraction. And if there is a borrow, if you borrow, as I said before, the borrow is going to be stored in the carry, right? If there is a borrow, so now I have to subtract R3. So what I want to do, R1 minus R3 minus borrow, if you borrow. You got what I'm saying? And this is done here by subtract with borrow. Okay. Again, it's similar idea to add with carry, but if there is a borrow, you have to subtract it from here. It's exactly the same idea. Okay. Anyway, I think that's enough. Okay, guys. Thanks.